Factoring the greatest common factor. So the first thing we have to do is find the greatest common factor between 6, 15, and 21. So for 6, I'm just going to write them all out this time. 1 goes into it, 2, 3, and 6. 15, 1, 3, 5, and 15. 21, 1, 3, 7, 21. So the greatest common factor that we have in all of them would be 3. Also in each term, I have an x, and the smallest exponent of the x's is 1, and I also have a y. So my greatest common factor is 3xy. Now, what I'm going to do is I'm going to divide out 3xy out of each term. So the first one, 6 divided by 3 is 2, and the x's and the y's cancel. Plus, 15 divided by 3 is 5. If I start with 2 x's and take 1 away, I'm left with 1x. If I start with 2 y's and take 1 away, I'm left with 1 y. Minus 21 divided by 3 is 7, x squared y squared. So my final answer is right there. Let's look at another one. So this time, I'm looking for the greatest common factor. Well, in this case, I have one term here and one term here. A term is separated by a plus or a minus. And the only thing I have in common is b minus a in each term. So this is my greatest common factor. So what I'm going to do is I'm going to factor out a b minus a out of each, which means those will cancel, and left over, all I have in that first term is x. Those will cancel, and all I have in the second term is 4. So I've now factored the original problem.